Hey everyone, I'm Sanjana. Today I'm going to be talking about LLM as a judge prompt optimization. LLM as a judge is an evaluation method where we use one LLM to judge the output of another LLM. So I kind of have this flowchart here where we have an LLM output, we feed that into our judge. Along with that comes a prompt template. Maybe you're testing for hallucinations or summarization quality or toxicity. And then after that, it's going to output a score or a label saying this output hallucinated, this output didn't hallucinate, something like that. But the really tricky part comes in when you're trying to actually nail this prompt. And there's a lot of ambiguity behind LLMs. There's a lot of non-deterministic behavior. So even if you write the best prompt template that you possibly can, you're probably going to have to iterate on that because accuracy might be low. It could be taking a lot of time to run. It could be expensive. There could be bias based on what model you're using. So we're going to take a look at a couple of these problems today. The first one we're going to take a look at is improving accuracy, and we're going to try to insert some few shot examples. And then I'm also going to talk about the importance of human annotations in all of this. And then we're going to talk about reducing cost and latency. It could be taking a lot of time to run these evals, which might not be beneficial. So we're going to use meta prompting to see if we can condense the prompt while maintaining all the important information that we need. Then we're going to talk about bias. You could be in a situation where your judge is evaluating certain writing styles or certain tones as worse or better. So we're going to try a style-invariant method where we try to actually just look at the content of the writing more than the tone and the style or anything like that. And then finally, we're going to look at self-refinement, which is similar to chain of thought prompting, but it's like an iterative LLM as a judge method. So we have a couple different things to go through today. I'm going to jump into a notebook where we can test all of this out. So let's just get right into it. I've went ahead and done some setup here. As always, I brought in the latest version of Phoenix, datasets, and open inference instrumentation with OpenAI. We'll be using OpenAI today. And I've also brought in the relevant API keys that we need. The next key part of this is loading in a dataset. So Phoenix has a lot of pre-built evaluation templates for LLM as a judge, and that's going to cover a lot of common use cases. I mentioned some earlier, but hallucinations, toxicity, Q&A correctness are among some of them. But oftentimes you may end up in a situation where you need to build an evaluator for something that's maybe a little uncommon or something that we don't have. That's what we're going to be focusing on today. So a cool use case might be an evaluator that's going to judge the level of empathy and emotional intelligence a chatbot may have. Some use cases for this might be like a mental health chatbot or customer support interactions, and you want to make sure that the level of attention and care your customers are getting are meeting a certain bar. I went ahead and loaded in a data set here, and I'm going to take a look at what that looks like in Phoenix. But what we have is a bunch of example responses that a chatbot might give, as well as an empathy score that goes along with it on a scale of 1 to 10. This is going to serve as our ground truth label in this case. So that was an example of a really high score, and a really low score maybe, I can't really help with that, maybe talk to someone else. And we're going to take a look at how our judge performs against these examples, and we'll use those ground truth labels as a marker of accuracy. So now the first thing to do is actually create a baseline prompt that we're going to iterate on, and I'm going to do that using meta prompting. So I have this meta prompt here that I'm going to feed into a model, and it's going to output a prompt for us. A couple things to call out here is that I said I really want it to have distinct evaluation criteria, include a strong scoring system on a scale of 1 to 10, because that's what our ground truth labels are. So no matter what our prompt decides, it should have a number score at the end of it. And a couple other things here, like including justification, some format specifications, and a scoring guideline. So I'm going to go ahead and run that, and we'll see what our initial template is. Okay, so now that that's finished generating, we can actually see what our prompt looks like. It seems like we have a couple of metrics that our judge will be looking for, such as like empathetic response capability, emotionally appropriate responses, handling of complex and subtle emotional cues. And with each of these metrics, it's also giving us a pretty robust scoring rubric, which is nice to see. So I'm going to go ahead and actually just save that to Phoenix now, so we can make iterations on this and go back and see some of our old versions. So if we go to our prompt hub, we can see that this prompt now lives in Phoenix, as well as model configuration details that go along with that. And now our next step is to actually start testing this initial prompt to see what our baseline performance is in terms of accuracy, latency, other metrics that we want to take a look at. So I went ahead and instrumented our application so we can actually collect traces and click into them. And the next step after that is defining our task and evaluator in this case. Because we are assessing LLM as a judge here, our task is using this LLM classify function, which is how we run LLM as a judge in Phoenix. And it's going to take in our data frame, the prompt template we just generated, a model that we're choosing to use, Rails, from the range of 1 to 10, so we can ensure that the output is going to match what our ground truth labels are. And then finally, I also indicate that I want an explanation provided. And then in our evaluator function, what we're doing is taking the output from this task and comparing it to those ground truth labels that I had defined earlier. And with all that set up, I'm going to go ahead and run this experiment with our task and evaluator, and then we can jump to Phoenix and actually see what's happening. Okay, so I've cut ahead to this finishing its run. And if we go into Phoenix, we can see that we had a performance of about 43% here. And let's see what's happening a bit closer. So let's click into this one over here, where our judge was deemed to be correct. In my evaluation function, I said that if the scores were less than or equal to 2 apart, then we'll consider that to be correct. And if we go to this track completion span, we can actually see why our LLM chose this certain response. And we can see the same if we go to an incorrect example. So for example, this had an empathy score of 6 in reality, but our judge chose a higher score of 9. So our next step here now is trying to bump up that accuracy. So the first way we're going to do that is by using few shot examples. The benefit of having few shot examples is that you can train your LLM to recognize what a low score might look like or a high score, and there's less ambiguity behind what it's determining. I'm going to show you how to use Prompt Playground to iterate on our current prompt, and then we'll do it in code as well. But you can go ahead and take these examples. This is our prompt template, and we can go into Playground and edit. I'm going to paste that right in there. So this is our original prompt. And then at the bottom, I'm just saying, to help guide your reasoning, compare your text to the following examples and scorings to make some adjustments there. And we can save that, update our prompt, and if we go to prompts, now we can see our second version lives here with our few shot examples added in. But to do that in code, we can just run that cell and then say that our improved template is our original template plus these few shot examples, because we're storing these as strings here. And once again, I'm going to run the same task and evaluation and experiment as before. I've redefined the task here because we are using a new prompt, but everything else remains the same. And with that, I'm going to go ahead and run our experiment. So I've cut ahead to this finishing its run, and right off the bat, we can see that with our few shot examples, accuracy is a lot higher, but latency has shot through the roof, probably because more reasoning is being done. Our prompt is now longer as well, but let's see what's happening again. And let's click into an incorrect response and go to track completion here. We can get a sense of why our judge is choosing this score of a 7 instead of a 10, so we have some adjustments to still be made. In cases like this, where it's a little tricky to nail those closer approximations, human annotations really make a big difference to catch those edge cases. And while these are really expensive to do because you're likely going to have more than 30 examples when you run something like this, a little bit goes a long way. So I'm going to go ahead and show you how you can make an annotation. I'm going to call this one correctness with the label of bad. And this wasn't too far off. The points were 3 apart. So I'm going to go ahead and say the score is maybe like 0.2, and you can define those scales as you see fit. And when I go ahead and save that, that feedback is saved over here, and this will help me when I go back to, catch some incorrect labels and maybe see how I can adjust my prompt based on these kinds of behaviors. And we can also see that feedback component right over there. Now that we've kind of seen one iteration of this, let's go into our next one, which is going to be reducing bias. We may be in a situation where our LLM considers more formal responses to be correlated with higher empathy or higher emotional intelligence, whereas more casual responses may be considered to be lower scores. And we want to sort of even out the playing field and do this style invariant evaluation, as I'm calling it here. So at the bottom of our prompt template, instead of adding our few shot examples, in this case, we're going to add a couple of examples showing different tone styles and saying these kind of responses all result in the same score. So we have an example of a formal response, a casual response, and more of a direct response. And once again, what I'm doing is taking this string, attaching it onto our existing prompt. And once again, we're going to get into the swing of this process where we redefine our task with our new template, and everything else stays the same, our model, our rails, providing an explanation. And then we are going to use the same evaluator as earlier. And I'm going to go ahead and now run our experiment. Okay, so that took a moment, but let's continue our same procedure. We go to Phoenix, we reload this. And we can see that Style-invariant actually performed pretty well, not quite as good as the few shot examples, but still better than what our initial prompt was putting out. Our latency had a slight improvement from our few shot examples, but still 4 times longer than our initial prompt. And we can follow the same procedure of clicking into our traces, seeing why certain explanations were chosen. Now that we have some more experiments run, we can do side-by-side comparisons as well, and maybe see that with this example over here, it failed on the Style-invariant addition and the initial prompt, but with few shot, we were getting a correct response. I've been calling out latency a couple times now, so that segues nicely into our third iteration here about reducing cost and latency. So how this is going to work is we're going to go back to our meta prompting strategy that we initially used to generate our prompt, and we're going to instruct our meta prompt this time to take in our current prompt and extract all the important details from it and condense it into a more precise and less wordy prompt. And hopefully with that, we can see some latency reductions without having a overly dense prompt running through the LLM classify function every single time. So I'm going to run that. So this is finished generating, and we can see that it pulled out the same ideas from our initial prompt with having certain metrics and a robust scoring scale, but compared to our initial prompt over here, this is significantly more condensed. And we use our LLM as a classify function in our task. We run our experiment, and let's see what's outputted from this. Cool. This is now finished, and if we go to Phoenix, we can see some pretty interesting results here. So right off the bat, latency is doing a lot better with this condensed prompt compared to what was happening with Style-invariant and few shot examples. But what's really cool here is I'm seeing our highest accuracy actually coming from this condensed prompt. I can't exactly pinpoint and tell you why that's happening, but that's kind of ties into the fact that LLMs are non-deterministic, and you need to test different things like this to see what behaviors might work best with your model and your use case and your data set. And if we go in here, go to check completion, we can see our condensed prompt and more explanations as to why this is working the way it is. And to continue our iteration process, the final step that we're going to be looking at is self-refinement, which is an iterative LLM as a judge process, which is a mouthful to say. But essentially what we do is our similar process of tagging on an extra component to our current prompt. And what this is saying here is that after you've done the evaluation, follow these 2 steps. One is self-critique, where we review the initial score, kind of take a thinking step. This is really similar to chain of thought prompting, as I mentioned earlier, where we do more step-by-step reasoning and explicitly tell our model in the prompt to do that step-by-step reasoning. And then after that reasoning is done, we do our final refinement step where we still output this number 1 through 10. So running that, and then we run our experiment with our improved prompt template with this iterative LLM as a judge. Okay, it's now time to see how that one did. And self-refinement, we reload. And we had good accuracy improvement again, similar to few shot, which is interesting to me, but not quite as high as the condensed prompt. Our latency wasn't the greatest here, but it also wasn't as high as I thought it was going to be, considering that we were asking the LLM to do more thinking and reasoning after everything was done. But I'm happy with this accuracy that came out of this. You can take a look at what worked in your use case, what didn't with these different iterations, and maybe combine some of these to get the goal that you're looking for. So that's what I'm going to do in my final step over here, where I combine some techniques. I'm going to take a look at our initial prompt along with few shot examples, and then I'm also going to throw in the style invariant aspect of this too. And you could do different combinations of this, but this is just one I chose to demo, and let's see how that performs. And maybe our latency might be worse, but our accuracy is higher. And it just all really depends on what you prefer and what works for your use cases. So our last and final experiment has now finished, and going back to Phoenix, we can see that the accuracy prediction that I had was correct because this is significantly higher than anything that we've seen so far, but our latency was also the highest. Something to mention is that I've been saying latency a lot, but cost and token count is also something that you could be considering here as a metric for how well this is performing. This is just one combination that could be done. I might go ahead now and try out the condensed prompt along with some few shot examples to get that low latency but higher accuracy along the way. It all really depends on what your use case is and what your goals are when making these evaluators, but I hope from all of this you've taken away some good iteration techniques and learned how to test these out using Phoenix and understanding what's going to work best for you. Thanks.